Welcome. Bipolar junction transistors. A diagram of NPN transistor. We have collector, base, emitter, note the direction of the arrow. One is towards the base, the other one is towards the emitter. We have this rear area of a transistor, and the definition of a transistor is a three-terminal device capable of switching and amplification. By switching, it acts like on and off. In cutoff, it acts like an off switch. In saturation, it acts like an on switch. By amplification, is that it converts a low power to a high power, and that is amplification. Learning outcomes: define terms transistor, identify parts and types of BJT transistors, describe BJT transistors, highlight types of BJT transistor configurations. A BJT consists of two back-to-back PN junctions manufactured in a single piece of a semiconductor crystal. These two junctions give rise to three regions called emitter, base, and collector. A junction transistor is a sandwich of one type of semiconductor material between two layers of the other type. A PNP transistor consists of a layer of N-type material sandwiched between two layers of P-type material. NPN transistor has a layer of P-type material sandwiched between two layers of N-type material. The emitter, base, and collector are provided with terminals which are labeled as E, B, and C. The two junctions are emitter base junction and collector base junction. We have emitter base and collector base. The symbol is shown. This is for a PNP, where the arrow points towards the base, coming from the emitter pointing to the base. For NPN, the arrow points from the base to the emitter. This is a schematic symbol, and this is a diagrammatic symbol. The arrowhead in the symbol is always at the emitter, not at the collector. And in each case, each direction indicates the convectional direction of the current flow. For a PNP transistor, arrow points from emitter to base, meaning that emitter is positive with respect to base and with respect to collector. For NPN transistor, it points from base to emitter, meaning that base and collector as well is positive with respect to the emitter. In a transistor, normal operation collector and base have the same polarity with respect to emitter. Emitter, its main function is to supply majority charge carriers, either electrons or holes, to the base. It is more heavily doped than any of the other regions. Base. It forms the middle section of the transistor. It is very thin, that is 10 raised to -6 meters, as compared to either the emitter or collector. It is lightly doped. Collector, its main function is to collect majority charge carriers coming from the emitter and passing through the base. In most transistors, collector region is made physically larger than the emitter region because it has to dissipate much greater power. Transistor biasing. For proper working of a transistor, it is essential to apply voltages of correct polarity across its two junctions. For normal operation, emitter-based junction is always forward biased. Collector-based junction is always reversed biased. The positive of our power supply is connected to the positive of the PNP, and the positive again here is connected to the negative. So we have negative connected to positive, that is the VCC, and then we have VEE connected also to the end of the P-type, and the kind of current we are getting is the emitter current. Here we are getting the collector current and the base current. So it's like the emitter current it goes to a junction, and then it leaves as base current, and also it leaves as collector current. So we can draw a relationship. Emitter current is equals to base current is equals to collector current. So emitter current is equals to base current plus collector current. Two batteries respectively provide the DC emitter supply voltages VEE and collector supply voltage VCC for proper biasing the two junctions of the transistor. Positive terminal of VEE is connected to P-type emitter in order to repel or push holes into the base. The negative terminal of VCC is connected to the collector so that it may attract or pull holes through the base. For a PNP transistor, both collector and base are negative with respect to the emitter. The collector is of course more negative than base. For NPN transistor, both collector and base are positive with respect to the emitter. The collector is more positive than the base. Transistor currents. The three primary currents which flow in a properly biased transistor are emitter current, base current, and collector current. For the common base, it is seen that IE is equals to IB plus IC. IE flows into the transistor, whereas both IB and IC flow out of it. And you can see of the 100% of emitter current, only 2% flows at the base, the 98% flows to the collector. So 98% added 2% gives us the 100%. By normal convention, current flowing into a transistor are taken as positive, whereas current flowing out of it are taken as negative. Hence, IE is positive, whereas both IB and IC are negative. Applying Kirchhoff's current law, we have IE plus IB negative plus IC negative is equals to 0, or IE is equals to IB plus IC. This statement is true regardless of transistor type or transistor configuration. Transistor circuit configurations. There are three types of connections or configurations for operating a transistor. Common base, the CB, common emitter, CE, common collector, CC. The term common is used to denote the electrode that is common to the input and output circuits. Because the common electrode is generally grounded, these modes of operation are frequently referred to as grounded base, grounded emitter, and grounded collector configurations. Since a transistor is a 3-terminal and not a 4-terminal device, one of its terminals must be common to the input and output circuit. Take-home tips. A BJT consists of two back-to-back PN junctions manufactured in a single piece of a semiconductor crystal. For normal operation, emitter-based junction is always forward biased. Collector-based junction is always reverse biased. Basically, there are three types of connections or configurations for operating a transistor: common base, CB, common emitter, CE, and common collector, CC. Quiz. Define the terms transistor, emitter, base, and collector. Draw circuit symbol of NPN and PNP transistors. Illustrate transistor biasing for either BJT type of your choice. State Kirchhoff's current law and how it relates with transistor currents. Outline three transistor configurations methods. The references are as shown. If you have liked this presentation, give it a thumbs up and subscribe to the channel. Thank you. I've been your trainer, Francisco Mbogwangige, Electrical and Electronic Department, JNNP, and I have my YouTube channel. You can follow for these lessons and the previous lessons and for other related units. Thank you very much.